Good day! Welcome to Educational Technology Online Tutorial. I am Vincent Abellano, a third-year college student of Amando College, taking up Bachelor of Secondary Education major in Mathematics. And this is my partner, Dharwin B. Camata. He is also a third-year college student of Amando College, taking up Bachelor of Secondary Education major in Mathematics. In this video, you will learn the easiest and convenient way of expressing long sum. Our topic for today is all about summation notation. Do you have any idea what summation notation is? Summation notation is a shorthand way of expressing a sum. It uses the Greek letter sigma. Sigma notation is a concise and convenient way to represent long sums. Consider the sum of the first 5 squared numbers. This can be written in sigma notation as the summation of k squared, where k runs from 1 to 5, is equal to n times the quantity n plus 1 times the quantity n plus 2 all over 6. Later on, we will know the solution of the sum of the first 5 squared numbers. But now, let us discuss the parts of the summation notation. N is called the upper limit of the summation, and it tells us when to stop. 3. K equals to 1 is called the index of the summation. And it tells us what integer to start subbing in to create the terms of the sequence. And 3k is the formula used to generate each term of the sum. Now, let us tackle the different rules that we will use in our discussion. First rule of the summation is the first constant rule in general form. The summation of C, where k runs from 1 to n, is equal to the quantity n minus k plus 1 times the constant. Let's take this as an example. The summation of 2, where I runs from 1 to 3, is equal to the quantity n minus k plus 1. Substitute the value of n and k. The value of n is equal to 3 and the value of k is equal to 1. Negative 1 plus 1 is equal to 0 times 2. It will become 3 times 2, and 3 times 2 is equal to 6. And another first rule of the summation, but this time it is in the simplified form. But take note that this is only applicable to a summation with an index starting at 1. The summation of C, where I runs from 1 to n, is equal to n times the constant. For example, the summation of 2, where I runs from 1 to 3, is equal to the n times C. Substitute the value of n, which is 3, and the value of C, which is 2. 3 times 2 is equal to 6. Another rule for summation notation is the second constant rule of summation. It states that it appears to be a rule about multiplication, wherein you can move a factorable constant outside a summation operator. Say for instance, the summation of C times AI, where I runs from 1 to n, is equal to the summation of AI, where I runs from 1 to n times the constant. Let's take this as an example, but before that, let's keep this in mind. That the summation of I, where I runs from 1 to n, is equal to n times the quantity n plus 1 all over 2. For example, the summation of 3i, where I runs from 1 to 5, is equal to the summation of I, where I runs from 1 to n times the constant. 3 times the quantity, the summation of I, where I runs from 1 to 5. Substitute the value of n, which is 5, so it will become 5 times the quantity 5 plus 1 all over 2 times 3. And it will become 3 times 15, and 3 times 15 is equal to 45. And the last rule of summation notation is the distributive rule of summation notation. It states that the summation of the sum of the given two terms is equal to the sum of the individual summation. The summation of the quantity AI plus or minus BI, where I runs from 1 to n, is equal to summation of AI, where I runs from 1 to n, plus or minus the summation of BI, where I runs from 1 to n. Let's take this as an example. Summation of the quantity 2i plus 3 where I runs from 1 to 5 is equal to 2 times the summation of I where I runs from 1 to 5 plus the summation of 3 where I runs from 1 to 5 is equal to 2 times the quantity 5 times the quantity 5 plus 1 all over 2 plus 5 times 3. 5 plus 1 is equal to 6 times 5 is equal to 30 divided by 2 is equal to 15. 2 times 15 plus 15. 2 times 15 is equal to 30 plus 15 is equal to 45. I hope you can catch up with our discussion. Now, let's explore some important theorems that will better help us to understand what summation notation truly is. The first theorem will help us to find the sum of the consecutive number, and it is the form summation of k where k runs from 1 to n is equal to n times the quantity n plus 1 all over 2. This was the note that I was referring to. For example, 58. The summation of I where I runs from 1 to 50 is equal to n times the quantity n plus 1 all over 2. Substitute the value of n, which is 50. 50 times the quantity 50 plus 1 all over 2. 2,550 divided by 2 is equal to 1,275. The second theorem will help us to find the consecutive squared number, and it is written in the form summation of k squared where k runs from 1 to n is equal to n times the quantity n plus 1 times the quantity 2n plus 1 all over 6. Let's take the given example a while ago. Say for instance, you were asked to find the summation of the first 5 squared number, and it can be written as the summation of I squared where I runs from 1 to 5 is equal to n times the quantity n plus 1 times the quantity 2n plus 1 all over 6. Substitute the value of n, which is 5, so it will become 5 times the quantity 5 plus 1 times 2 times 5 plus 1 all over 6. 30 times 11 all over 6. And 330 all over 6 is equal to 55. The next theorem will help you find the sum of the consecutive cube numbers, and this can be written as the summation of k cubed plus where k runs from 1 to n is equal to n squared times the quantity n plus 1 times 2 all over 4. Say for example, summation of I cubed where I runs from 1 to 50 substitute the value of n, which is 50, so it will become 50 squared times the quantity 50 plus 1 squared all over 4. 50 plus 1 is equal to 51. 50 squared times the quantity 50 squared all over 4. 50 squared is equal to 2,500, and 51 squared is equal to 2,601 all over 4. 2,500 times 2,601 is equal to 6,500,500 all over 4, and the answer is 1,625,625. Isn't it amazing to find a long sum but in a concise and convenient way? But before I end the discussion, I will give you an exercise to test that you really learn from us. Evaluate the following. Number 1, summation of the quantity 2i minus 3i squared where I runs from 1 to 10. Number 2, summation of 4i where I runs from 4 to 7. Number 3, the summation of I squared where I runs from 1 to 7. Number 4, the summation of the quantity I plus 4 where I runs from 1 to 5. Please comment down your answer. For more online tutorial, please visit our channel and don't forget to subscribe. That would be all. Thank you.